Hey guys, welcome to another video. Today's learning objective is to apply and interpret a limit of accuracy, and for the higher tier as well, is including upper and lower bounds. As usual, feel free to skip to any part of the video. Timestamps are here. Okay, so first off, what are limits of accuracy? Well, if you remember from, what happened there? Just move back to there. If you remember from last video, right? We talked about how we round and why we round in life. So let's go back to our example of that ruler. So it was that piece of string rather with the measure with the ruler. So let's say, yeah, there we go. This is our ruler. And if I came up to you and said it was 14 centimeters and that I've rounded to the nearest centimeter, do you know that, for example, that it's only accurate to that nearest centimeters? So it could have been, anything as small as 19.5 centimeters, or anything as big as 14.5 centimeters. And that's the limit of accuracy, that I only know it's only accurate to for example, one decimal place, because I said it's 14 cm to 1 dp. And basically this is where upper and lower bounds come in. Sorry, 13.95. 13.5. Yeah, so this is where upper and lower bounds come in. When I tell you it's 40 centimeters to 1 dp, at most, it could have been 14.5, and at least it could have been 13.5. So this is the lower bound, and this is the upper bound. Okay, let's move on to a question, and I think it will become a bit more clear. Where's the question gone? There we are. Here's the question. Okay, so a bag of apple weighs 7 kilos. Correct to the nearest kilogram. What is the least possible weight of the bag of apples? Okay, so we've got a bunch of apples that weigh 7 kilos, and it's correct to the nearest kilogram. So when you see this question like this, it's really helpful to say, just underline this key information. That's correct to the nearest kilogram. So that means, say if it was, I don't know, 7.3 kilos. Well, you could have, if we were to round to the nearest kilogram, we'd go to 7 kilos, right? Say if it was 6.8 kilos. Well, again, we'd round to 7 kilos, to the nearest kilogram. And the least weight at which we round to 7 kilos would be 6.5, right? So when you see a number like this, and you know it's rounded to the nearest kilogram, so you say 7, and it's rounded to the nearest kilogram, so it's a place on the right to it that can be changed. So you think, what's the number here that could, that allows us to round to 7? So at the top bound it will be 7.5, and then this number again would be 5, but you decrease this number by 1, and then you get 6.5. So your upper bound is that, and your lower bound is that. So the least possible weight it could be is 6.5 kilos. And make sure you write the kilos. That's make sure you include your units. A lot of the time people forget to do that. Okay, let's move on to another question. The length of a rectangle is 9.9 centimeters, correct to 1 decimal place. The width of a rectangle is 1.92 centimeters, correct to 2 decimal places. Calculate the upper and lower bounds of the perimeter of the rectangle. Give your answer to 3 decimal places. Okay. So this basically, when we're doing a compound measure, so this perimeter, remember what perimeter is, right? We've got a table and we added the length, width, right? So since we do that, since we have to compound it, there's a degree of error in this length and some error here. So we want let's find the lower bound first. Well, to find the lower bound, we need the least the perimeter could be. And since the perimeter is just adding all of these, it's the least the length could be, plus the least the width could be, and then again. So 9.9 is correct to 1 decimal place. So I'm just going to go ahead and highlight that, or underline it, and that's correct to 2 decimal places. So 9.9 cm, okay, correct to 1 decimal place. So this is the one that could be changing. So it could be anything as large as 9.95. So because it's 1 decimal place, we're considering this one. So we think about whatever it comes up in this spot here. or it could be anything as small as 9.85. And with the 1.92 centimeters, it's corrected 2 decimal places. So we think about the thing here, so it could be anything as large as 1.925, upper bound, let me just write that, upper bound, lower bound. It'd be helpful to write, say, length here, and width. And have, say, that upper, and its lower bound will be 19.915. So if we want the total lower bound, well, we can just do the perimeter of, so we calculate the perimeter using the lower bounds of each of these. So we go lower bound of perimeter is equal to 2 times by 9.85 plus 2 times by 19.915, which is equal to, I'll do that in a second, and upper bound of perimeter is equal to 2 times by 9.95 plus 2 times by 19.925, which gives us, okay, so, well, suppose we don't have a calculator for this, we have to do this by hand. So we can do 9 times by 2, which is 18, plus 8.5 times 2. So what you can do is, because this 5 is here, there's a 5 here, right? So you can do it as 8 plus 9, so 17, so that'd be 7 here, and there's a 9 there. So you carry that, plus 2 times by 19.915, that's a bit of a harder one, so I'll get the multiplication table out, that cross multiplication, 9.5. See, what's really important is if you're not like me and you kind of miss copy, and I've lost so many marks for that, so just make sure you don't kind of lose marks for something as silly as kind of copying this incorrectly. So 5, that becomes 0, carry the 1, 2, that's 2, and then 3, 18, carry the 1, 18 again, 19, carry the 1, 2, 3, 39.830 plus 39.830, which is equal to, I'll have to kind of have another side for that, and then just make a bit of space, sorry. Okay. So, what is that, 19.7, and then 39.830, 0, the 3, and then 8 plus 7, 15, carry the 1, 9 plus 9 plus 1, 19, 1 again, 4, 5, then don't forget this decimal point is equal to 59.530, and that's already to 3 decimal places, so we're lucky, VDP. Okay, we can do the same thing here, 2 times by 9.95. Well, the quick trick here is if we kind of, going back to our estimation topic, we can just round this to 10, that's 20, but then there's this 0.05 that we have to kind of minus, and we have to do that minus it twice. We minus 0.1, so that becomes 19.9, plus, and then again, well, actually I'll just do the good old cross multiplication here. So it's 2, and then 9. Yeah, and by the way, if you're bored of me kind of doing these cross multiplications, feel free to skip to wherever you need to go. So yeah, again, really important to have clearer handwriting than mine, because what happens here is that kind of you end up making some mistakes because of this. And then 2 again, so then we carry, so 18, all of that, 18 again, and then we add 1, so 19, 2, and then 3, so 39.840. And quick trick here is that it's the same thing as this, but you add 0.2 here, and you add 0.1 here, so that becomes 59. Add the 0.2, and then 0.1, so 4, again 3 dp. And there you go. That's it. We're done. I hope that video made sense. This was a bit harder. Upper and lower bound, I remember they challenged me a lot when I was kind of doing this. So again, really important to you practice, cover and review the things that we talked about in this video. But see you guys in the next one. And now let's do the upper bound. So for upper bound of perimeter, we have, so 2 times by 9.95 plus 2 times by 19.925. Okay, so quick trick here is that if you round this to 10, and this is actually using the estimation stuff we did last video, kind of. If we round this to 10, that will be 20. But then there's this kind of, we have added on an extra 0.05, and we've done that twice, right? So it'll be 20 minus 0.1, which is 19.9. And then we can add, okay, well, I'm going to do cross multiplication again for this. So 19.925 times by 2, okay. Look at the time sign, 5 times 2, 10, 0. So we carry the 1. 2 times 2 is 4, plus 1, 5. 2 times 9, 18. And we carry the 1. 2 times 9, 18 again, plus 1, so 19. Don't forget the decimal point. Carry the 1 again. 2 times 1, 1, plus 1, 3. 3.985. 39.85. So. And if we add that up, we should get 59.750 to, again, 3 dp, as we needed in the question. And also, what's really important is to give our, because we know this is in centimeters, we need to give our units. So it's really important we go back, put centimeters and centimeters. So a lot of the time when I see units in the questions, what I'll do is actually I'll just go and underline it. I'll be like, okay, that's a reminder to me when I'm done with the question to make sure I put my units, because there's a lot of marks a lot of the time there are marks available for just putting your units down correctly. And it was also very helpful to underline, say, 3 decimal places, just to remind you that you need to give your answer in 3 decimal places. So in general, whenever I see a question that's a bit more complicated, you can go ahead and underline the key pieces of information just as a reminder, kind of what you need to do. But yeah, I hope you guys enjoyed that video. It was a bit of a longer one. There's a few different things that we covered. So it's really important that if this stuff is new to you, to go ahead and do some worked examples, do some practice questions, some exercises. I know this tripped me up so many times when I was doing it. So, and there's a few things that you do need to learn. So, but yeah, I hope you guys did enjoy that. See you guys in the next one.